Hello, this is OCR Further Statistics. We're in Bivariate Data 3, Lines of Regression, and the second video, using the line of regression. We're going to use the same example as the previous video. So it's a Hooke's law experiment where m is the mass attached, controlled by the experimenter, and L is the length of the spring. In this situation, where we have one random variable and one non-random, the regression line predicts a theoretical true value of the random variable for a given value of the non-random variable. So if our data looks like this, the regression line, going through the middle, will give an estimate of the true length of the spring for a given mass. We might then be asked to use the regression line that we have calculated. Here we are given a value for m and asked to find L. So our GCSE method would be to read this from the graph. Locate the value of m equals 4.2 on the x-axis, read up to the graph, and across to read off the value of L, approximately 29 centimetres. More accurately, our A-level method is to find an equation for the regression line, which we did in the last video. Now we simply substitute m equals 4.2 into the regression equation. Giving us an answer of 29.322, which we round sensibly to 29.3 centimetres. We can also use the regression line to work the other way. If Simon needs the spring to stretch to 30 centimetres, he can calculate what mass he will need. Simply substitute in L equals 30, and rearrange to get m equals 30 minus 21.3, all divided by 1.91, and an answer of 4.55497, which we round sensibly to 4.55 kilograms. Why is it inappropriate to use this model to predict the length of the spring when a weight of 10 kilograms is attached to it? Well, we only have evidence for weights in this range. In this region, the data is linear. If we predict results in this area, we call it interpolation. Outside of these points, we have no evidence. We call this extrapolation. We don't know if the data will remain linear, curve upwards, or curve downwards. In fact, it is known that Hooke's law breaks down if you stretch a spring too far. The spring has a limit where it starts behaving differently. And of course, ultimately, there will be a breaking point. Note that we would also be extrapolating if we looked at weights which are smaller than the ones we've applied. It's not safe to make predictions that involve extrapolation because we don't know how the situation will behave. That's the end of this video on using lines of regression. In the next video, we'll look at regression lines where both variables are random.